Hello everyone, my name is Mohit Gupta and I welcome you to my YouTube channel CAM Fundamentals. In today's video, we are going to discuss equilibrium, that is how to solve numerical. This is part 4. The rest of the parts are given in the description box as well as I button over here. So without further delay, let's get started. So in today's video, we are going to discuss how to calculate the equilibrium concentration of reactants and products. For this, you need two things, the initial concentration of the reactants as well as what is the value of the equilibrium constant. So this has 5 major steps. The step 1 is you have to write down the balance equation. After that, you have to express the concentration of reactant at equilibrium in terms of X. So X is the amount of product that has formed and minus X would be the concentration of reactant that has decreased. How to write it, we'll see later. The step 3 is you have to use the stoichiometric coefficients to write down the equilibrium constant. Then you know the value of constant, then you can easily determine the value of X, and from the value of X you can find out what is the concentration of reactant and product. If the stoichiometry is 1, it would be X. If stoichiometry is 2, 1 by 2, whatever, it would be 2X or so on. So let's start with an example. I have taken a general example. 2A plus B is giving us C plus 2D. This is a equilibrium reaction where A and B are the reactants and C and D are the products. So initially I have taken, let the concentration of A be A and the concentration of B be B mole per liter. Okay, so since the reaction is in initial state, that means the reaction haven't started yet. In that case, the concentration of product would be 0. After some time, when the equilibrium will reach, at equilibrium, some of the amount of C and some of the amount of D would have increased. I have taken it X. Since the stoichiometry of C is 1, I have taken it 1x, and since the stoichiometry of D is 2, I have taken it 2x. Now, what is the amount of A and B has decreased? We can easily write it like this: B minus X, because the stoichiometry is 1 here, so I can write it down B minus X, and since the stoichiometry is 2 here, I can write down A minus 2X, which means 2 moles of A are combining with B. So double the concentration of A would decrease as compared to the B. Same as the concept over here. Now we'll come to the step 3. We'll write down the formula of Kc. So Kc would be C into concentration of D raised to power 2 divided by B into A concentration of A raised to power 2, as its stoichiometry is 2. Now from that we'll substitute the value of X at equilibrium. This would be X into 2x ka whole square divided by B minus X divided by A minus 2x raised to power 2. And from this we can easily determine the value of X, and from X we can find out the concentration of C, that would be X. Concentration of D at equilibrium would be 2x, concentration of B would be B minus A, and concentration of A would be A minus 2x. Fine. So let's take an example and let's try to solve it. So in this example, I have taken the question: calculate the equilibrium partial pressure of the carbon monoxide and carbon dioxide if the value of Kp is given as 3.0 and the initial partial pressure of carbon dioxide is given as 0.48. So the reaction is CO2 plus C give us twice of carbon monoxide. In this case, the initial concentration of CO2 is given. However, carbon is a solid, so we can ignore its concentration because its activity or the concentration would be taken as 1. Okay, so initially the pressure of CO2 would be 0.48 and of that of carbon monoxide would be 0 because the reaction haven't started yet. At equilibrium, the concentration of CO would be 2x and the concentration of CO2 would reduce from X. So that would be 0.48 minus X. Since the stoichiometry of CO2 is 1, therefore I have subtracted it as minus X. If it would be 2 twice of CO2, I would have written 0.48 minus 2x. Okay, so the next step is you have to write down the value of Kp. The formula of Kp is partial pressure of carbon monoxide raised to power 2 divided by the partial pressure of carbon dioxide. Now substitute the value at equilibrium. It would be 2x raised to power 2 divided by 4.8 minus x, which is equals to 3.0. The value of Kp is already given to us. Now we have to simplify it. What I'll do, I'll multiply 0.48 minus x to 3.0, and what I'll get 2 square, which is equals to 4x square, is equals to 0.48 into 3 is 1.44 minus 3x. Now I'll take all these things on left hand side. What I'll get, 4x square plus 3x minus 1.44 is equal to 0. So this is your quadratic equation. And how can you solve the quadratic equation? You can solve it using this formula. The roots of x would be x is equals to minus b, this is your b, plus minus under root b square, you have to square the 3, minus 4ac. 4 is constant, a is your 4 and c is your this. So this is your ax square plus bx minus c is equals to 0. So you have to substitute all this value. On solving it, what you will get x is equals to 0.33 bar. You will get two roots, one in positive and other in negative. So you have to ignore the value of negative one because the concentration of product cannot be in negative. So you will choose the positive one where x is equals to 0.33 bar. Now the pressure of carbon monoxide is 2x, so you have to multiply it by 2. You will get 0.66 bar. Similarly, the partial pressure of carbon monoxide would be 0.48 minus x. You will minus the 0.33 from here. What you will get, 0.15 bar. So it is pretty simple. The two main things here is you have to know how to write down this, and you have to know how to solve. You can, if you are at home, you can easily use any online tool to solve the quadratic equation, but I'll suggest you do it by yourself. So let's take one more example. The initial concentration of ICl is 0.78 molar and Kc is given as 0.14, and we have to find out the equilibrium concentration of reactant and product. The equation is twice of ICl is in equilibrium with I2 plus Cl2. So the initial concentration of ICl is already given, 0.78 molar, and the concentration of the products is 0 because the reaction haven't started yet. At equilibrium, what I'll do, I'll write it down x. Since it is also 1 mole, I'll write it down x, and since it is 2 mole, what I'll do, I'll subtract it by 2x. 0.78 minus 2x. So next step is you have to write down the formula of Kc. It is pretty easy. Then just substitute the value of these in this. What you will get, Kc is equals to x into concentration of x divided by 0.78 minus 2x raised to power 2. Now on solving it, what you will get this. On further simplification, we will get 0.14 into 0.78 minus 2x whole square, which is equals to x2. Now what I'll do, I'll take under root on both the side. Doing so, what I'll get, x square would become x. I'll get under root of 0.14, and under root of this whole term would be same, 0.78 minus 2x. So now the equation is very simple. We can easily solve it. Under root of 0.14 is 0.374, which on multiplication with 0.78 minus 2x would result in this equation. I have further simplified it, and at the end what I'll get 0.292 is equals to 1.74x, and then x would be 0.292 divided by 1.748, which is equals to 0.167. Hence, since the value of x is this, the concentration of I2 is equal to the concentration of Cl2, which is equal to x, and hence the concentration of Cl2 and I2 is 0.167 molar. However, the concentration of reactant is 0.78 minus 2x. So on solving it, what I'll get, the concentration of ICl at equilibrium is 0.446 molar. So it's very simple. You have to follow simple steps. Let's take one more example. This is a little different example. I have taken 0.482 moles of N2 and 0.933 moles of O2, and both are placed in a vessel with a volume of 10 liter. See here what you have given, you haven't given the concentration, you have given the moles and the total volume. So you have to find out the molarity first, and at the end the value of Kc is 2.0 into 10 to the minus 37. This is the equation. Initially the number of moles is 0.482 moles and 0.933 moles, and initially it would be present in zero concentration, and the number of moles would also be 0. Point to be noted here, I haven't written the molarity here, I have written the number of moles here. At the end I'll convert it into the molarity just for my convenience. So at equilibrium it would be 2x, I have to subtract minus x, and I have to subtract minus 2x since the stoichiometry is 2 and 1 here. So the molar concentration would be, I have to take this divided by the volume, which is equals to 10 liter. So I have to divide 10 on all the places just to determine the concentration. We cannot use number of moles directly into the formula, that is molar concentration. Okay, so Kc is extremely small in this case. We can see here that is 10 to the power minus 37. And I have already told you in the last part that when the value of Kc is less than 10 to the power minus 3, the reaction is in initial state. So when the value of Kc is so less, so we can ignore the x with respect to the reactant concentration. So what we'll do, we'll ignore the 2x and x, and it won't make any difference. Okay, so on substituting this, what I'll get, 2 divided by 10 is 0.2, so 0.2x square divided by 0.482 divided by 10, which is equals to 0.0482 raised to power square into 0.0933, and the value of Kc is already given, 2.0 into 10 to the power minus 37. After solving it, what I'll get, x would be equal to 3.3 into 10 to the power minus 20. Now you can see the value of x is very small, so if you minus it from the 0.482 or 0.0482, it would be negligible. So it's better to ignore it just to make our calculation little easier. Now the concentration of NO2 would be 0.2x, 2x divided by 10, which is equals to 0.2x, and you will multiply x. What you will get, the concentration of NO2 is 6.6 into 10 to the power minus 21. Now you can see here the value is into 10 to the power minus 21, negligible, almost negligible. So now we reach to the homework. So I have given you two questions. These are the two questions. You can take screenshot or you can write it down, whatever you like. Just solve it. I'll give you answer in next part, or if you have any problem you can write down in the comments below. So this is it for the today's video. This is Mohit Gupta signing off. Have a great day.